Welcome to Chapter 5. In this chapter, we are going to be working on something called trig identities. In section 5.1, we are going to work on simplifying trig identities, which means taking something involving these sines, cosines, tangents, etc., and we want to make it smaller. So our first idea here is to be able to look at what we have. Hopefully the identities that we have listed in this chart look fairly familiar, and we're going to rewrite them in a couple different forms. So the ones up on the top, let's see, involving cosecant and involving secant, those should look pretty familiar. But the ones that have sine squared plus cosine squared, that one we've seen maybe once or twice before. The others involving tangent squared and cotangent squared, those are the ones I'm going to focus on the next page. And what I'm going to do is rewrite them, getting sine squared all by itself or tangent squared all by itself. So let's take a look as we rewrite the Pythagorean identities. Starting with the sine squared theta plus cosine squared theta equals 1, I can add and subtract to both sides of this equation. And the first thing I'm going to do is get sine squared all by itself. So I'm going to subtract off my cosine squared from both sides. So that sine squared equals 1 minus cosine squared. So this is another way to represent the original identity that we had in terms of sine squared and cosine squared. I'm going to repeat this process. This time, here goes sine squared theta plus cosine squared theta equals 1. And I want to get cosine squared all by itself. So I'm going to subtract off sine squared. And that'll let me say that cosine squared theta equals 1 minus sine squared theta. So I now have 3 different representations of the original Pythagorean identity. So up here, my original Pythagorean identity was the sine squared plus cosine squared equals 1. The others, where I have plain sine squared equals or plain cosine squared equals, are different options. And I would like to be able to use those down the road. And so I'm going to take this idea of my original Pythagorean identity and then rearranging it with the other 2 Pythagorean identities, the one involving tangent squared and the one involving cotangent squared, and I'm going to work on that on the next slide. Okay, so tangent squared theta plus 1 equals secant squared theta is our original Pythagorean identity, and I'm going to start this by subtracting off 1 so that I get tangent squared all by itself. And what I have here is one of my new versions, or it's a rearrangement that's supposed to be tangent squared. And now I'm going to repeat the process, working with getting the 1 all by itself. This doesn't happen very often, but you never know. Maybe I want to get tangent and secant squared on the same side. And so now I have 3 different ways to represent my Pythagorean identity involving tangent squared and secant squared. And last but not least, I'm going to look at the identity involving cotangent squared in a second. Okay, so in our cotangent squared Pythagorean identity, I'm going to subtract off 1 from both sides to get the cotangent all by itself. So that I now have, if you can read my handwriting, cotangent squared equals cosecant squared theta minus 1, and that is just a different representation of the original Pythagorean identity. And then I'm going to repeat the process. I'm going to get the 1 all by itself. So that I can have the cosecant squared minus cotangent squared. And now I have 3 different ways to represent the cotangent squared and the cosecant squared Pythagorean identity.